All right, example number 4. We'll change the function. We'll make it a rational function, the reciprocal function, 1 over x, at the point 2, comma 1/2. Again, using the h goes to 0 limit definition for the slope of the tangent line. So again, we know that a takes on the value of 2, and f of a takes on the value of 1/2. So we can make that substitution in. I'm going to leave the little limit thing out for now. We know that at the end we're going to take the limit. Just kind of a pain in the butt to continually write that down. So let's substitute in what we know. We're going to have f of 2 plus h, again our a value is 2, minus 1/2, because f of 2 is 1/2, over h. Our function is 1 over x, so I'm going to have a 1 over 2 plus h, minus 1/2, all over h as my fraction. And then I got to... Hi, Mr. Brackland. Then I'm going to go ahead and simplify this set of fractions here. Getting a common denominator of 2 times 2 plus h for the numerator is going to leave me with a 2 in this denominator, 2 in this numerator, and 2 in this numerator. So 2 minus the quantity 2 plus h. So there's the combined fraction all over h. 2 minus 2 is 0. And then I have a negative h over 2 times 2 plus h. And then that h gets dragged into the denominator of the upper fraction, leaving me with this rational expression. And again, I know I've done it right because my h's have to cancel. If the h's don't cancel, it either means I've given you a discontinuous function at the value that I'm asking you to look at, or you've made an algebraic mistake. I'm not going to give you ones that don't work, so it would probably be your algebra to go back and check. So my h's cancel, and I'm left with finding the limit as h goes to 0 of negative 1 over 2 times 2 plus h. We know that h going to 0 just changes this, so 2 plus 0 is 2, 2 times 2 is 4, that limit is negative 1. If you want to, you can work with both equation 1 and definition 2 and show yourselves that in fact you get the exact same answer regardless of which method you use. However, you should practice using both. Don't fall in love with one because you will be asked to show your skills at both definition 1 and equation 2 on an assessment. So please know both of those, know the setup, and be able to work them. Okay, the last video I'm going to show is going to be about velocity in physics and instantaneous rate of change. So that's the last one to watch, and then you should be good to go with your homework.